us for teachers also. So I again welcome you and I will start my lecture. Uh, this is lecture number 5 of this development program, student development program. So in the very first lecture, Dr. Reddy has given the solution, told about the solution of homogeneous system of equation, and he explained the things very beautifully, right? We start from the equation, linear equation in one variable, ax is equal to 0, and then continue using that concept. He continues up to a linear equation, m equations in n variables, and he told about the solution of homogeneous system of equation, and delivered by Dr. Reddy. Now, the after that, the main course was started by Dr. Sunil Kumar Sharma, and he talk about vector spaces and subspaces, which are the building blocks of linear algebra. If one should want to learn linear algebra, right? So he or she should be clear about this web definition of linear algebra. So this lecture is linear algebra, a geometric approach by S. Kumarisan sir. So it's a nice book, and we are also learning from this book. Uh, so today I am going to talk on. I will talk on linear combination. What is a linear combination? How it came into existence, right? Then we will talk about the linear span, and if time allows, I will try that. We will talk about linear dependence also. So for this today's lecture, I am taking a vector space, and you all know that what are the vector spaces. If anyone has a doubt that what are the vector spaces, then he or she can unmute the mic, and right? Unless until in some questions it is not described that the field is C or something like that, I will take the set of real number as a field. So next definition of vector space. section of subspaces. But before that, I have one point in my mind. If I see that V is over vector space, then can you tell me the subspace of V? Anybody else? Can you tell me any subspace of V? If V is a vector space,
Yes.
yes, 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 Vishal, please.
एक तो जीरो मतलब एम्प्टी ना एम्प्टी सेट.
Okay, empty means singleton set zero, not
Yes, a
empty.
singleton set zero. And
And
V
and
itself.
any other? Okay, okay, very good, very good. So see, we all know that each set is a subset of itself, right? So V is a subset of itself, and V is itself a vector space. So V is a subspace of itself, right? And most of the students are writing yes. That means they know the thing. It's good. So V is a subspace of itself. So if V is a subspace of itself, then space, we first of all look for a non-empty set, right?
Yes, sir.
So in the definition, if you can write that W is a, if I cut this thing, that W is not a non-empty set, then there is one element zero
Yes, sir.
belongs to W. So from
Yes,
this
sir.
we can say that W is a non-empty set.
Yes, sir. Yes,
So
sir.
in some books it is written that W is a subspace of V if first point zero belongs to W, right?
Okay,
So
okay, sir.
that only represents that W is a non-empty set,
Okay, sir.
right?
Thank you. Thank you, sir.
That only clarifies that W is a non-empty. So I
Thank
have
you, sir.
written both of the things. It doesn't matter, right?
Yes, sir. Yes, sir. Yes, sir.
Okay. Thank you, Pavan. So it's a good thing that students are discussing. So just like Pavan has a doubt, so don't keep the doubt in your mind, right? You are free to discuss. Either you will learn a new things, or I will, or the teachers with me learn a new thing. So it's a good for mathematics, right? So this is our first things which we have observed that as Vishal Chandel has pointed that V has a two subspaces that we called as a trivial subspace. Trivial means just like we have a system of homogeneous equation and zero zero is the solution. Now result one which Sunil sir has discussed in yesterday lecture,
Sir,
that if
Akanksha
we have
want to
two,
ask something. Akanksha.
yes Akansh, yes,
Hello, sir.
yes Akansha, please.
Sir, I want to ask that you have written zero belongs to W. Is it identity represent identity element or element zero, real number zero?
It's belong to a vector, right? So it's like a theta.
Okay, sir. It means it is a identity element.
Yes, yes, yes. It's an
Okay,
event.
sir.
Okay. So let us see result number one, that if we have two subspaces, I am taking two subspaces W1 and W2. Uh, I will write the subspace like this, less than equal to. If W1 is less than equal to V means W1 is a subspace of V. And if I write W2 less than equal to V means W2 is a subspace of V. So this is just a notation. So if W1 is a subspace of V and W2 is also a subspace of V, then what can we say about W1 intersection W2? If we take intersection, then what can we say? This was written by Dr. Sunil Kumar Sharma. This was discussed by him in the yesterday lecture, that this is also a subspace of V, right? W1 is a subspace of V, W2 is a subspace of V, then its intersection, if we take the intersection of W1 and W2, that is also a subspace of V. So can any, if I will call any student, Samriti is there, Samriti. Yes, Samriti.
Yes, sir.
Samriti, क्या आप, will you tell me that how we can prove that W1 intersection W2 is a subspace of V?
The proof
सर, ओके। मैं थोड़ा वो ऊपर वाला भी इनको शो करना चाहता, नो प्रॉब्लम। यस उपासना।
Sir, because alpha x plus beta y belongs to W1, also W2. It means it belongs to W1
Upasana,
intersection W2.
Upasana, just wait. X, Y belongs to W1 intersection W2.
Yes.
So, what about X and Y for W1 and W2?
So X. So what?
X and Y belongs to intersection. So
Yes.
first
It
clear
means
this
X
condition.
belongs to W1 and X belongs to W2.
Yes.
X belongs to W1 and X belongs to W2.
Is only X belongs to W1 or Y also belongs to W1?
So Y also belongs to W1 intersection. Hmm.
So why you write and क्यों बोला आपने ये बीच में? इंटरसेक्शन में आपने एंड क्यों बोला ये?
This is because X belongs to W1 और W2 को भी बिलोंग कर रहा है, मतलब इंटरसेक्शन को बिलोंग कर रहा है, तो ये मतलब करेगी.
It means
Okay,
X
that means
belongs to W1 and X also belongs to W2. Then
Yes.
only X belongs to intersection.
Yes.
Yes.
okay, Upasana, you are going in the right direction. I want to discuss with another student, Rekha Rani. Rekha Rani.
Yes, sir.
Yes, Rekha. Will you tell me how we will proceed further? Hurry up. If X comma Y belongs to W1, then W1, as it is given that W1 is a subspace. So what can I write now? Rekha, are you getting the things which we are discussing?
Yes, sir.
Sir, let us call somebody else.
Kanika is there. Yes, Kanika. Rekha, you see this.
Yes,
Kanika,
sir.
please come. Yes, Kanika, बताएं.
सर हमें दिया है कि W1 और W2 V के सब स्पेसेस हैं, वेक्टर
Right.
स्पेस हैं,
Right,
V के
right.
सबस्पेस हैं. तो सर दिस मीन्स 0 belongs to W1
Okay.
and also 0 belongs to W2.
Okay.
Sir, this means 0 belongs to W1 intersection W2.
Right.
It means W1 intersection W2 is non-empty.
Okay. This is first point.
Yes, sir. So अब हम W1 intersection W2 में दो एलिमेंट्स ले लेंगे X, Y.
ले लिए.
Yes, sir. अब since X, Y belongs to W1 intersection W2, this means that X and Y belongs to W1
Yeah. Right.
and also X and Y belongs to W2.
Right. Carry on.
Sir, as W1 is a subspace of B, so this implies alpha X plus beta Y belongs to W1 for any scalars alpha and beta.
For any alpha, beta belongs to scalar. Alpha
Well,
X
sir,
plus beta.
well, sir, you have used it C1, C2, so better you use that.
Okay.
Kanika, I hope you don't have any problem if you use C1, C2.
Yes, sir.
Okay.
That also belongs to W1.
Yes,
Next,
sir.
Kanika.
Sir, W2 is also a subspace, so for any scalar C1 and C2, C1X plus C2Y also belongs to W2.
Okay.
So this implies C1X plus C2Y belongs to W1 intersection W2.
Right. Okay. This shows that W1 intersection W2 is a
Subspace.
okay. Thank you, Kanika. Good. So I think this should be clear to all of you. We have done. We have given. I think 10 to 15 minutes to this theorem. So if you have any doubt, you can write in the chat box. Otherwise, write yes so that I came to know that you are okay. I should get response in 10 seconds, right? All of your responses. Okay. So we can extend this theorem to our arbitrary intersection of subspaces also. Suppose I have W1, W2, so on. If I have a finite collection of subspaces, right? If I have a finite, or you can say arbitrary, but I am writing for a finite collection of subspaces of V, then you can say that intersection I is equal to 1 to n Wi is also a subspace of V. This is the sign for subspace, right? So don't confuse in this sign. This is less than equal to is the sign for subspaces. You can write it for arbitrary also. So next theorem which was discussed by Sunil sir was their union. So I will go quickly because I have to start today's topic also. But making sure that you have a concept of subspaces, right? So, so in yesterday lecture, if we have two subspaces, W1, W2 are the subspaces, then sir has discussed that their union need not to be a subspace, need not to be a subspace of V, right? If W1 is a subspace of V and W2 is a subspace of V, then W1 union W2 need not to be a subspace of V. So whenever we have to prove that this is not, that means we have to create some example, or we have to seek for some example which will not satisfy this thing, right? So in the yesterday lecture, some student has given the example that if we take vector space R cube over R and W1 is a subspace like this, x0, 0, and x belongs to a real number, right? And W2 is a subspace like this, 0, y, 0, and y belongs to real line. Then their union. Now, what is their union? Anybody? Anybody will tell me?
XY0.
Okay, x, y, 0. Somebody is saying x, Anchal, I think, is saying that this
Yes,
is
sir.
x, y, 0 and x, y. Anchal, I am writing. You please tell me whether I am writing a correct thing or not. Is this what you want to say,
Yes, sir.
Anchal? Okay. So this is a subspace or not? Okay, let us see geometrically. Uh, Reddy sir has given a very beautiful line that think geometrically, solve algebraically. So let us see it geometrically. That if we have r cube, this is over x-axis, this is over I take z-axis, and this is over y-axis. So x0, 0. So if I write it as a capital x-axis, or this is z, and this is I write that. So this is x00 point, right? This is on x-axis. So if I take x is equal to 1, 2, 3, or any real number, I will get this line, x-axis, right? So I will get this x-axis. Now if I take a W2, and this line also passes through origin, you can go backward also in the negative sense, but I am not drawing. And W2 is over also a subspace that is 0, y, 0. That means if I take any point here, right, it belongs to this. This is also a line, right? This is also a line, and passing through the origin. And we all know that the line passing through origin are the subspaces. So that means this x-axis and y-axis are the subspaces. Now, what Anchal has told that W1 union W2 is XY0. So, are you agree with Anchal that union comes out to be XY0? Hurry up. Yes, students, are you?
Yes, sir.
Yes, yes. Yes, Gaurav sir, you want to say something?
Please write yes if you are agree, no if you are not agree.
Okay, so Vishal, Kakran, Pavan Kumar, they are saying no. Anybody else who is saying no?
Vishal,
Yeah.
can you unmute your audio? Vishal.
Yes,
Vishal
sir.
Kakran.
Yes.
Yes. Yes, Vishal, you can discuss.
Sir,
Yes,
in
Vishal.
union
Yes.
we take collection of elements of W1 and W2, and elements of
Right.
W1 are straight line, which is x-axis, and elements of
Right.
W2 are straight line, which is y-axis. Then collection will be
Right.
points on these lines only. But if we are taking
Okay.
xy0, this is R2.
Yes,
We are
this is
taking
in
R2.
plane.
It's a plane.
Right.
So that
Okay.
union is not a plane. That union is just elements of those two lines.
Right. Right, Vishal. You are saying very correctly. So, Anchal, you are not correct here, and you will keep this thing in your mind uh, that we are taking union, right? We are not adding them. So, if we take a union, that means all the elements like this x00 and all the elements like this 0000 and all the elements like this x01 and all the elements like this x02 So union is need not to be a subspace, and further we have to apply some condition on this result so that W1 union W2 is a subspace of B, and that condition we will discuss later on. Now, if you have any doubt or you are clear up to here, then kindly write yes, or if you have any doubt, then let me know that you have a doubt. Yes in 10 seconds. I need yes or no in 10 seconds. All of you, 63, uh, approximately 55 students are with us. Okay. Anchal is saying yes. No problem.
सर
I am. Yes, yes.
सर मुझे
Yes,
एक छोटा
Priya.
सा कंफ्यूजन है
Yes.
सर जैसे हमने यहाँ पे W1 यूनियन W2 को लिखा x00 कोमा 0y0 सर तो हम इसे शॉर्टली में ऐसे नहीं लिख सकते xy0 जैसे हमने यहाँ पे एग्जांपल में प्रूफ किया जैसे यहाँ पे W1 यूनियन W2 लिखा था 100 और W1 यूनियन W2 लिखा था 010 फिर यहाँ पे हमने इसे प्रूफ किया कि ये सबस्पेस नहीं है तो हमने इसे शॉर्टली में लिखा 110 तो हम यहाँ पे क्यों नहीं लिख सकते सर
Beta,
Anchal,
we are adding here. Yes, yes.
Anchal, आप बताओ ये क्यों लिखा 110? Anchal,
Yes, sir.
you tell us why we write 110. Which
Sir,
property
because
we use?
sir addition properties use की यहाँ पे.
Addition, vector addition property.
Yes, sir.
Yes. So when we add these two vectors, what we get?
Sir, I think Anchal is clear about this. Anchal, are you clear about this?
Yes, sir.
There is a problem to Priya. Doubt is related to Priya, I think. Okay, Priya, you
Priya,
please
yes.
unmute your mic.
Yes, sir.
So sir is saying why
Yes,
we
Priya?
are writing like 110 doesn't belong to W1 union W2.
Priya, what is
The question
VA1?
is, okay, Priya,
Vector
you
addition
think
property 1,
geometrically.
VA1.
Priya, you think geometrically. Sunil sir, can I tell her about
Yes,
that?
Rohit sir, you
Okay,
yes, you can.
okay, sir. Priya, if you see that your doubt is that why we are not writing XY0, right? Why we are not writing XY0?
Yes, sir.
Because if we see that W1 is the line, is the points on a x-axis. All the points on x-axis is in W1. Is it okay?
So, yes, sir.
Now, all the points on y-axis are also in W2.
Yes, sir. I am agree.
Okay. Now, if we take union, so in union, what you take? All the points on of W1 and all the points of W2.
W2.
That means
Yes, sir.
all the points on x-axis and all the points on y-axis. So that
Yes,
comes
sir.
in the union. Is it okay?
Yes, sir. Yes, sir. Yes, sir.
Is this point comes in the union which I have draw circle? I will mark with another color. If I write this point, is this point comes in union?
Yes, sir.
ये union में आ रहा है. Is it on x-axis or y-axis? This point
Sir is
which I
in
have marked,
x-axis.
this is on x-axis,
Yes, sir.
but x-axis is here. Yeah, x-axis is this, in which
Sir,
y and z
x-axis
coordinates
में
are 0.
सर
This
x-axis में
point
x
doesn't
वाले
lie
पॉइंट्स
on
लाई
x-axis.
करेंगे.
Yes,
Rohit
this
sir,
yellow point. Yes, sir. Yes.
it's better if you represent y with another color, y axis with another color, and x
Okay,
with
sir.
some other color.
Okay. Okay, Priya. I will make easier for you. Uh, I will I will talk about r square. Suppose I have this r square. Now this is over x-axis. Is it visible to you?
Yes, sir.
And this
Yes.
is over y-axis. Now if I consider all the points on x-axis, so can you say that this point lies on x-axis?
Yes, sir.
This point is on x-axis. क्या ये point इधर इसके ऊपर lie कर रहा है इस axis के ऊपर?
It also represent y-axis.
It lies in the plane first quadrant, not on x-axis,
Yes.
neither on y-axis. It lies on the plane. Yes, Gaurav sir, आप कुछ कहना चाहते?
I was just asking what is the representation of point on x-axis, Priya?
सर एक्चुअली मेरा मतलब ये डाउट था कि जैसे हमने वहाँ पे x मतलब जैसे लिखा था ना हमने वहाँ पे पॉइंट्स में 1100 तो मतलब मेरे यही पॉइंट था कि हमने वहाँ पे उसके कॉमन्स लिए x00 y00 मतलब मेरा ये क्वेश्चन था कि हमने पॉइंट्स में अलग कैसे लिखा और ऐसे रिप्रेजेंटेशन अलग क्यों लिखी.
वही बता रहे हैं कि सर एक पॉइंट जो है वो एक्स एक्सिस पे लाई कर रहा है, दूसरा पॉइंट जो है वो वाई एक्सिस, मतलब एक सेट जो है वो वाई एक्सिस है, दूसरा सेट एक्स एक्सिस है.
Yes, sir.
So we have two sets. Then its union will be union of these two sets. Either point will lie on x-axis or y-axis. But if point lie on this xy first quadrant, other than x-axis and y-axis, then we cannot say it lies
is also a subspace of V. We have studied. Now, if I take any S subset of V, right, and S also belongs also a subset of W1, S also a subset of W2. W1 S should also contained in W1 intersection W2. Only I can write that S is contained in W1 intersection W2, and W1 intersection W2 is a subspace of V. So I can say, what can I say about this W1 intersection W2? That W1 intersection W2 is a smallest subspace. It's a subspace we have seen, but it's a smallest subspace of V containing S. Now I have added one more thing to the subspace, that is the smallest. Why? Because W1 intersection W2 is a subset of W1, and similarly W1 intersection W2 is a subset of W2. So from all the subspaces containing S, W1 intersection W2 is the smallest one containing S. That's why I am calling that this is the smallest subspace of V containing S. Right? I am repeating again what I am taking. First of all, we have to search a subspace that should contain S. But I am adding one more thing. What is that? We have seen that if W1 is a subspace of V and W2 is a subspace of V, then their intersection is also a subspace of V. Now I am taking a subset of V, S. S is also belongs to W1. I am assuming this, and S is a subset of W2 also. Naturally, S is a subset of W1 intersection W2. So what we get here, that S W1 intersection W2 is a subspace of V containing S, and I am calling this that this is the smallest subspace. Why smallest? Because if W1 intersection, we can say that W1 intersection W2 is a subset of W1. Intersection is always a subset of.
Sir, your audio is mute.
Now is it okay, sir?
Yes, sir.
My audio is mute now, or it's a long time?
10 seconds before.
Okay, I don't know why it's mute. Okay, no problem. So students, we want to search not only WS, that is a subspace. We want to search a smallest subspace. We want to search a smallest subspace containing S. Right? So when we say that our subspace is smallest, I will say that W is the smallest subspace of V containing S. When I say that, suppose I have another subspace U, I will call it U, and that contain S, and that is a subspace of V. Less than equal to means subspace of V, and this is a sign of subset. When I say that WS is the smallest, when WS contained in U, and WS is a subset of U, then I say that U is any arbitrary subspace containing S, and I say that WS is a smallest subspace. And overall search is for this smallest subspace. Yes, if you are clear up to now here, then kindly write yes in a chat box. Otherwise, write no. I will explain it further. Okay, hurry up, yes. Okay, repeat. Shweta is saying repeat. Shweta, I will not repeat the whole thing. I will tell you that what is our main question. Main question is that if we have any subset S of V, right, and we want to search a smallest subspace, we want to search a smallest subspace that contains S. That is our question that we want to search. We are calling it as WS. Just like in diagram, we have a vector space V, and this is over subset S. We want to search a smallest subspace which contain S, and the smallest word comes from the intersection. That means there exists. Uh, we are not saying that arbitrary. That means there is a subspace. Smallest word is existing in this because of this intersection. So we can search a smallest subspace which contain S, and that we call as WS. We are searching for that thing, right? So how we will proceed further? So for proceeding further, uh, I am taking a singleton set first. Suppose I am taking a singleton set V, which is a subset of V. Further, I am taking that V is not equal to 0. So what is our question, Shweta? Shweta, our question is, we want to find a smallest subspace. I am writing it, denoting it as WS. We want to find a smallest subspace containing S, right? S is a subset of V, it is a singleton set, and we want to find a WS. What is the description of WS? So, Muhammad, you have some doubt. Yes, please. S is a subset of W1, S is a subset of W2, and S should be in W1 intersection W2, right? So you are saying that, okay. So you're saying that S is a subset of W1 intersection W2 or W1 intersection W2. S is a subset of W1 intersection W2 because we are saying that S W1 intersection W2 is a subspace of V containing S. That's what we are saying. That is the smallest subspace. So the smallest word is existing. So that's why we are talking about smallest subspace. Now let us take a singleton set V containing small element V, and V is not equal to 0. So what is the description of? We want to see the description of WS. Keep the things in mind that WS is a subspace. WS is a subspace, and WS is also should be a smallest. Smallest I have defined that if there is any subspace of V containing S, then WS is a subset of that space. Just like if I take example of height in your class. Suppose I have a smallest height in your class is 4.5 feet. So when I say that this is the smallest, this is smallest because if I compare with other students, then the height of the other students should be greater than the height of this 4.5 5 feet child, right? So then we say that this is a smallest subspace. So now we want to see the description of WS. Since WS is a subspace and it contains S, that means S is a subset of WS. It means, and S contain only a singleton element. That means V should also belongs to WS. And we are searching for a subspace. That means for any alpha belongs to real or any scalar, alpha into V should also belongs to WS, right? That means if I take a collection of elements like this, alpha into V, and where alpha belongs to a real line, so this set is a subset of WS, right? We want to see what is WS. We are in a search of WS. So we are moving like this way. Now call this let us call this set as W naught. Let us call this as W naught. You can easily verify that W naught is a subset of WS. sum of these two, then that should also contained in WS. So we can prove that again same thing. This is a this type of collection is a subset of WS. We call it as W naught, and W naught is a subspace as we have proved. You can prove here also. This is a subspace of V, right? And because WS is the smallest subspace and W naught is contained in that, so it should be possible only when WS is equal to W naught. And W naught is nothing that it should be alpha V plus beta W, and alpha beta belongs to R. Yes, if you are clear up to here, then please respond to me in a chat box. Hurry up. And if you have a doubt, I will. Okay. Okay. Let me ask somebody else. Yes, Nagita Thakur. Nagita Thakur. Nagita Thakur. Poonam Devi. Poonam Devi. Yes, Tanya. Tanya CS 441.
Yes, sir.
Yes, Tanya, are you clear what I am telling, what I am discussing here?
Yes.
Tanya, please unmute your mic.
Yes, sir.
Yes, what we are doing.
सर WS को हमने कंसीडर किया अल्फा V प्लस बीटा W, जहाँ पे अल्फा और बीटा बिलोंग कर रहे हैं R को. सर हमने प्रीवियस डिस्कस किया था कि WS इज इक्वल टू W नॉट, उसी का
Yes,
यूज
WS is
किया
equal
यहाँ
to
पे.
W. Okay, so basically what we are doing, we are finding the smallest subspace containing S. S is a subset of V. S is any subset of V, right? We are finding a smallest subspace which contained S. So how its description is, that's what we are searching for. First of all, we have taken a singleton element. Now we have taken a two elements, and now you please tell me that if I take three elements, suppose I will take S three elements, suppose U, V, W. That is a subset of V. Tanya, then what
Yes,
should be the description of WS? तो हम WS को कैसे लिख सकते हैं? Yes.
सर अल्फा U प्लस बीटा V प्लस गामा W, where alpha beta gamma belongs to R.
Okay. Alpha, beta, gamma belongs to R. I can also write it as alpha 1 U phi belongs to containing all finite linear combination. If I write S as V1, V2, so on, Vk, right? I have written already. Then their set of all linear combination are look like this, where k is some, you can say, a natural number, and I varies from 1 to k. I varies from 1 to k, and alpha I all are the scale. So linear span is nothing. It's the smallest vector subspace of V containing a given set S. So this is how we have generated a smallest subspace, and this is how linear span definition came into existence with the help of this smallest subspace. Right? Sangeet sir, I have 2 or 3 minutes, or should I stop here?
So you can take 1 or 2 minutes. No problem.
Okay, student, I will talk about one example and then I will stop.
Sir,
So
please ask.
example is,
Sir, please ask. Did they understand it? Whatever you have provided.
yes, sir, yes. So students,
Because I can give
are you
5 minutes to them if they need, but they will compile on time.
okay, okay. So students, basically, Shivani is saying something. Yes, Shivani, please unmute your mic. Please repeat linear span. Palvi Puri is saying. Shivani, you have some doubt.
You are talking about Shivani Puri.
Yes, sir. I am talking about that these vectors can be orthogonal vectors.
No. Don't go into it. It's okay. We will talk about it later. Did you understand what I said?
Yes, sir. Because orthogonal vectors can be written as linear combination. That's why I
We will,
asked.
we will talk about it at the end. Okay. So
Okay,
for
sir.
now, did you get it?
Yes, sir.
Okay.
Yes,
Sir,
Pallavi
you
Puri,
can take
you have also. Yes, sir.
you can take other students' question if any.
Okay, Pallavi Puri saying that repeat this, please. So Pallavi, I will revise the thing. We have taken one element in our vector space V, that is small v, and that is a non-zero, and we call that singleton set as S. What we have generated, we have find smallest vector space containing S. So that was alpha into V, and alpha belongs to a real number. Next, we have taken two elements. V and W, and again the vector smallest subspace is given by, that is alpha into V plus beta into W. Alpha beta belongs to R. I have discussed this thing. Next, we have taken three elements, and next k elements. So from this k elements, we have got the smallest subspace containing S as a set, and set is nothing but the linear combination of elements of V1, V2, Vk. This is how the linear combination is defined, right? So this set, this smallest subspace containing S is known as, we call it as linear span of S, right? So we have done up to now here. Now let us see one example which I think make
Sir.
you more clear. Yes.
सर इफ वी टेक ओनली अल्फा, लाइक जैसे आपने अल्फा 1 अल्फा 2 अल्फा 3 लिया, अगर हम अकेला अल्फा ओनली अल्फा लेकर चले, मतलब ओनली वन स्केलर अल्फा.
अल्फा फॉर व्हाट?
सर हमने स्केलर लिया ना, जैसे आपने पहले ओनली वन लिया था वी, देन वी एंड डब्ल्यू. सर फिर हमने V1 V2 V3. सर अगर हम अल्फा 1 अल्फा 2 अल्फा 3 ले रहे हैं यहाँ पे, अगर उसकी जगह हम सिर्फ अल्फा 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 लेकर, मतलब ओनली वन स्केलर लेकर चले.
Because we want to see all the linear combinations of these elements, right? If we take one alpha, that gives us only one linear combination. So if we or we can say that we will get only one variable multiplied with all three elements or two elements or a element. But we want a different linear combination. So that depends upon different values of alpha, beta, gamma. It's just a notation, but it's better to take Yes.
Yes, sir. Yes.
Okay.
Sir,
We
Yes,
want
sir.
all the linear conditions.
if we can
Yes, Gaurav sir.
if we can explain it geometrically, अगर आप इसमें कोई geometric example दे दें तो.
I am coming to that, sir.
Okay, okay.
The example contains the geometry, right? So suppose I have two elements, E1, I am writing it as 1, 0, and E2, that is over 0, 1. So I am taking a set S, and that set S also contains two elements, E1 plus E2 and E1 minus E2, right? I will write this example and then I will stop. So S is this. Now S is we are taking a vector space as R square, right? Because int we are taking the order pair, so we are taking a vector space R square over R, and S is a subset of V. Now we want to find the smallest subspace containing S, that is over linear span of S. Yes. Who will tell me? Yes, Taranpreet, will you please tell me how this linear span of S looks like? First of all, see this S. How this S looks like? It is E1 plus E2. Taranpreet, are you listening me?
Yes, sir. Yes, sir.
Then what is S? S. First of all, we have to see S, how S looks like.
E1 plus E1 plus E2.
What is E1 plus E2?
E1.
E1 is this,
One,
E2 is this.
1, 1. 1, 1.
1, 1.
Yes.
Okay. Then what is E1 minus E2?
It's 1, 1, sir.
It's also 1, 1.
Yes, sir.
1 is plus, 1 is minus.
Yes,
Sir,
sir. 1
1.
and minus 1. 1 and minus 1.
1 minus
0.
1. That means
Yes,
this
sir.
set contains two elements. One is 1, 1 and other is 1 minus 1. So
Yes.
Taranpreet, tell me the linear span of S, or the smallest subspace containing S. How can we write? We have two elements.
Two elements. It's alpha.
Yes, you are thinking right. Say what you are saying in your mind.
So it's alpha 1, 1 and alpha 1. Alpha 1, 1
Alpha 1,
and
1.
plus alpha 1 minus
Yes.
1.
Alpha, you are taking alpha.
So
Again,
beta,
right?
beta. Yes.
Okay. I can take a beta.
Beta, yes, sir.
Beta can be equal to alpha, but it's better to take a separate scalar.
Yes.
So alpha beta belongs to real. So this is over. This is over
Linear.
span of S. Is it okay? Can I
Yes, sir.
solve further? Can I modify it or write in another way? इसको कुछ और
Yes,
तरीके से लिख
so
सकते हैं?
it's alpha plus beta and alpha minus beta.
Right. So it is alpha plus beta and
Alpha
alpha
minus.
minus beta. So alpha is a real number currently,
Yes, sir.
right? And beta is also a real number. So what should be
Real.
alpha plus beta?
So it's R
What should be
square.
alpha? Alpha plus beta क्या होगा? Alpha real number है, beta real number. Then its addition will be
Real, also real number.
also
R
real
as-
number. So I call it as suppose I call it as x, or
Yes.
okay, call it as gamma, right? So what is
Yes, sir.
alpha minus beta? That is also a real number.
But yes, sir. But not gamma, na.
It can be anything else. I will write
Yes,
it
sir.
as delta. It's just
Yes.
notation, right?
Yes.
So gamma and delta belongs to R. Gamma and delta, because the sum and addition is also a real number. That is the property of real number, because R is a vector space. So can you think geometrically? Can I write linear span of S geometrically? Because we are taking a vector space as R square. So this is over x axis, this is over y axis.
Why?
So what is over LS? Yes. What is over LS? Linear span of S. Smallest subspace containing S. Yes. Anybody else? Yes. YC Negi. YC Negi. YC Negi.
Sir, Kavita.
Yes.
Kavita.
Kavita.
Yes, sir.
Yes, Kavita. If we want to see geometrically, what is linear span of S? What should be it? How you will see this?
सर एक्स वाई के कोऑर्डिनेट में आएंगे ये
XY. Okay, your answer. Think. Linear span of S is this set. हमारे पास ये जो है एक तरह से निष्कर्ष आया है. I am speaking in Hindi. Sorry. So this is what we have. Sorry, this is what we have got. That linear span of S is this. Yes. Anybody want to answer this question
Utkarsh Rajat.
or modify?
Yes, sir.
Yes,
Sir,
please.
sir, it is in the form of line passing through origin.
Okay, it is in the form of line. See, Utkarsh, see this carefully. Gamma and delta can be any real number. So
Sir,
if I
we can
take
ask others, please.
1. Okay, no problem.
Arup Datta.
Okay, sir. Arup.
R2 please.
So Arup is saying R square. How it is?
Because sir, we are that means taking RS such that RS are coming from R, so it will cover the whole. That means this is a subset of R2, and if I take any element from R2, then it will be in this set L of S.
Okay. So how many of you are agree with Arup? Kindly write yes or no. If you are agree with Arup, then kindly write yes. Akansha saying yes. Mukul saying yes. Aman yes. Anybody else who is not? Jyoti saying no. Yes, Jyoti.
Line parallel to
So why no?
y-axis.
Line parallel to
Y-axis.
y. So I am writing this. This is a line. So suppose this is over point 2. So that means this is over line. Y is equal to 2.
She meant
So
to say that
x is equal to.
gamma is not changing, right? She meant to say gamma is not changing. But
Yes, sir.
are. Gamma is any real number.
It will be set of lines parallel to y-axis.
Set of lines parallel to y. Then what will
Yeah, if we change, yeah, it will be like delta if we fix. So this will be that line. Like you will give me
Why
one
del-
delta.
the whole set if we combine all the lines?
Yeah, that will be R2. But fix delta, right? Lab delta 5. Then only I will get that line.
Yeah, neither the delta or neither gamma is fixed because they are the real number.
They are real
Right.
number, any real number.
So you can
Rohit
take
sir,
any point.
I think you leave them with this exercise and you can start tomorrow from here. Let them think about it.
Okay. So this I am stopping here, students. So
Tomorrow
if
we
you
will
have
start
any
from
doubt,
here.
okay, sir. So over to you, Sangeet sir. Thank you very much.
No, sir. If you want to say something, please say. I was just adding that
No.
we shall.
Now the discussion session is start your session and it's over to you. Whatever you want.
Okay, Sunil sir, are you saying something?
Yeah.
Gaurav sir, your voice is not clear.
Sunil sir.
I'm
Gaurav
not
sir, listen.
speaking.
Sunil sir, your voice is not.
Okay, quickly, in the meantime, I will talk to students. Students, today we are not taking any poll. There is one poll, but that is in the different way. So please listen carefully before answering. Just wait. Do not write anything until I complete. Okay. Rohit sir, please sir, write these options over here.
Okay,
There
sir.
are three options. Number one is yes always. First option is yes always. Yes always.
Okay, okay.
Second is no. Second option is no. Third option is sometimes.
Okay.
So students, the question or the thing that I want to know is like this, that whenever some teacher is explaining some concept or we are into the discussion, okay, so though we are trying to go very slow so that you can get the concepts. So the question for today is, are you able to think along the teacher whenever he is explaining some concept or going into the discussion? So you have to write yes always if you always find it. Or if you are not able to connect, you should write no. And if you feel sometimes we are going along, then please write sometimes. Please give your response in the chat box so that we can see that how many of you are getting the approach. So I repeat, my question is, are you able to think along with the teacher as soon as some discussion is going on? So you have three options: yes always, no, or sometimes. So we do not mind if you write no or sometimes. No need to worry about it. Please give your right opinion.
Yes, genuine opinion.
Yes, we want answer from everyone, all students who are sitting over here. It's very important for us because this is a kind of feedback that motivates us and allows us to do. And it will give us some idea that if you have to do something else apart from this. Make sure everyone has to give some answer. Every one of you. Are all done?
Only two responses I think we have got.
No. I think students have
Third
answered.
response. Answered?
Many students have answered it.
That maybe.
So if anybody is
Okay,
left,
there
please
is
write.
some issue here.
Yes. If anybody is left, please write your clear opinion. I already said, even if your answer is no, please write it. We will not mind it. This will help us as well as you also. So if everyone has given response, then thank you so much. If somebody is left, you can still write, no problem. And if you don't want to write here, you can write to me on my email also. You know that, okay? So you can share your opinion there also. I think this is done. So there's one thing that I was thinking of during the session. In the beginning, I announced that we are going to give the certificate to students who will attend 100% lectures, and they will have to score 50% marks in the quiz that we are going to conduct, one at the end of this week and one in the next week. So there may be one problem that some of the students may get disconnected at the end of session, because we usually take attendance either in the meantime or at the end or in the beginning. So it all depends. So somebody may have some connection issue. So there is one suggestion: if other people agree with me, all the faculty members agree with me, then what should be the attendance criteria? Sunil sir, Rohit sir, please mention it so that students should be clear about it. Earlier I said it was 100%, but sometimes students' connection gets disconnected. Gaurav sir?
Yes, sir. We can reduce percentage for attendance if student can attend 80% or 75, whichever you think is good.
I think 80% will be better in that case. So students, the criteria of attendance will be 80% from now. Okay. So 80% attendance. Secondly, two quiz, you have to score minimum 50% marks in that.
But student,
Only
you
then,
should try 100% from your side,
yes,
right?
yes. This is only for the students who have some connection problem. So we are giving this advantage to those students.
Because if you attend all these lectures in a routine, then you will get a very good knowledge of linear algebra, right? You will be able to see the new things, and it can help. These things can help you in future also. But if you break 2 or 3 lectures in between, then it will be very difficult for you to recapitulate the things and starting from the midpoint or starting from the point above mid, right? So it's better to be in routine. Yes, sir.
Yeah, that's right. Thank you so much, sir. So one more thing that I want to ask from some students, sir, can you please move to the slide when you took 2 elements and then generated a smaller subspace? Yes. Students, my question: do you all agree that S is contained in WS? How you have defined this WS? Do you all agree with it that S is contained in WS? Please give your response in the chat box. I will not take more than 1 minute. How many of you agree with it? That S is contained in WS? Mukul, can you unmute?
Yes, sir.
Okay. How you can say this, that S is contained in WS?
Sir, S contains singleton vector.
How?
That's given.
No. We have defined WS as alpha V plus beta W for some alpha beta belonging to R. How it contains V and W?
Sir, if V and W contain in S, then there is linear combination also contain in.
No, Viti. I'm not asking about WS. I'm asking whether WS contains this S or not. Okay, you please mute it. Akanksha?
Yes, sir.
Yes, can you answer it?
Sir, as we will belong to WS and W will belong to WS.
How it will belong to WS?
Sir,
Sadhana Upadhyay. Sadhana.
Okay, Aman Shukla?
हेलो
Yes, Aman.
जी सर, हमने अल्फा और बीटा जो लिया हुआ है, हमने रियल नंबर से लिया हुआ है, तो हम
Okay.
अल्फा और बीटा को रिस्ट्रिक्ट करके हम ये प्रूव कर सकते हैं कि वी और डब्ल्यू बिलोंग कर रहा है या नहीं कर रहा है। जैसे कि अगर हम
Okay.
अल्फा को 1 ले लें और बीटा को हम 0 ले लें, तो ऑब्वियस सी बात है, जब हम अल्फा इंटू वी कर रहे हैं तो हमें वहां पे वी ही मिलेगा, और सिमिलरली हम डब्ल्यू केस में भी कर सकते हैं सर, तो इस तरीके से हम प्रूव कर सकते हैं यहाँ पे।
Okay. Did you all students get it? Thank you, Aman. Very good. Did you all get it? How V and W are members of this? So you should think about it this way. So this is very obvious question that you should have asked from sir, or you should have discussed it.
One more question. Umar Farooq has written in this chat box. Umar, I think I have explained it earlier. We are taking S as a subset of W1, S as a subset of W2, and S as a subset of W1 intersection W2. Right? Because we are telling that W1 intersection W2 is a subspace containing S. If it is okay to you, then write in a chat box or
And sir, there was one question raised by Taranpreet also. Taranpreet, sir, what was her question at that time? She was talking about linear combination.
Yes, she was telling that can we take alpha and alpha throughout alpha v plus alpha w?
Uh-huh. So she got it. She was talking about one particular, taking one scalar only.
Yes. So have you got the idea, Taranpreet?
Yes, sir.
Okay, that's
Hello.
correct. Yes, yes, yes.
Yes, sir, I do.
Okay.
Sir, I want to raise one question for students so that they can think it.
Please, sir, please.
Students, please, if you can find a geometric example in which if there is one element in a set, then what will be its linear span in R square? If there are two elements in a set, then what will be its linear span in R cube? So if there are two elements in a set that two elements belongs to R cube, a fixed elements, then what will be its linear span in R cube? If there is one element R, one real number, and what will be its linear span in R square? So just think it geometrically. What will be the linear span of these two sets? If I'm talking about one element, then it will be like 1 0 or in R square 1 0 or 2 0, it is like that. And if I'm talking about two elements in R cube, then it will be like 1 0 0 0 1 0. It can be like this.
Rohit sir.
Yes,
Yes, Gaurav sir, please.
Then what will be their linear spans geometrically? How can you think about their linear span? So you will think about this, and we will discuss it tomorrow.
Yes, sir.
Sir, I wanted to say that whatever Gaurav sir is asking, you can note it down, and whenever you will post these slides in the Google Classroom, you can post this question over there. It will be good.
Sir,
Students will
I
see
have,
from there also.
Okay.
I have written it.
Rohit sir has already written, but I will again write it in a proper way.
Yes, that's good, sir. I think it will be better if we post it there. All students will be able to see it.
Sure, sir.
Yes. Jyoti, no problem. It will be posted in the Google Classroom. I hope you all are there. I hope you all are part of the Google Classroom. It will be posted there along with the slides. So you will get to know about it. So I think time is already 6:45, 54. So let us close the session if there's nothing to say. Anybody want to share anything? Gaurav sir, Sunil sir, Rohit sir?
No, sir.
It's okay from my side.
Yes, no, sir. I don't want to.
Okay. So students, if you have anything to say, you can say. Otherwise, we are closing for today. Thank you so much. Let us thank Dr. Rohit Gandhi sir for this interactive and very interactive and wonderful session. Thank you so much, Rohit sir. So if anybody has anything to share, you can stay and discuss. Otherwise, you can leave the meeting now. Thank you so much. We will meet tomorrow. We will resume back at 4:40.